Hi, good morning, guys. So I'm gonna do a free session today, right? In preparation for the 2022 CSEC Maths exam. In today's session, I'm gonna be focusing on some algebra topics, right? There'll be several sessions between now and the exam. So what I suggest you do is to subscribe and hit like so you'll know when I go live, right? I'm only going to be going live when I have the time available, right? So let's begin, right? Let's look at this first question here. So these are all exam type questions that you can get in the real exam, right? So let's look at this first question here, which is find the integer values which satisfies this inequality here. So we have 2, right, is less than 2x, which is less than or equal to 10. Now, when you have an inequality that looks like this, your objective is to get x in the middle alone, right? Now, if I want to do that, I need to get rid of this 2 here. And in order to do that, I must divide every single part of this equation by 2. So 2 divided by 2 is going to give me 1. The sign remains the same. 2x divided by 2 is going to give me x. I'm going to keep my same sign here. And 10 divided by 2 is going to give me 5. Now the question says, what are all, or find all the integer values that satisfies this inequality. Now, on a number line, right? Let's say I would have put 1 here, right? 2, 3, 4, and 5, right? So because of the inequality signs, this one here is going to be a circle that is unfilled. This here by the 5 is going to be a circle that is filled, right? Now my integer values, so our integer values, in this case here, x can either be, now it's greater than 1, so it can be 2, it can be 3, it can be 4, and it can include 5 because of that inequality sign there. X is less than or equal to 5. So those are my integer values for this particular for this particular question, right? Now let's do the second part here. The second part here now, we want to factorize this here, right? Now we have 6y squared. So we have 6y squared minus 15x. Now 15xy. Now according to your syllabus, there are 4 different methods of factorization that you need to be aware of. And that is the HCF method, the difference of 2 squares, factorizing by grouping, and the quadratic function, right? Now I've done many videos on these different types of factorizing, so you all can scroll through the videos that I have on my channel, and you can access them, right? There are lots of free material there that you all can use, right? Now we want to factorize this here. Now I only have 2 terms and they are separated by a minus sign. So some students, they look at this and they think, well, maybe it's a difference of 2 squares. But the thing is, 6y squared is not a square variable. 15xy is not a square variable. So what we're going to have to do, we're going to have to use the HCF method, right, to factorize this. And when you have to find the HCF, we first look at the whole numbers here first. So you have 6 and 15. So your thought process should be, what is the highest number that can go into 6 and 15, right? When I look at those numbers there, the highest number that can go into both of them is going to be 3, right? Then we have to look at our variables. Now there's no x in the first term, there's y squared, and the second term here is xy. So the only thing that is common to both of them, and that is the highest variable that can go into both of them, is going to be y, right? So what we're going to get now, you have to ask yourself, 3y multiplied by what is going to give me 6y squared? So 3 by 2 will give me 6, and y by y is going to give me y squared. You put back your minus sign. Now you have to ask yourself, 3 multiplied by what gives me 15? 3 by 5 is going to give me 15, right? Now, there is an x here, so therefore I need to put an x here, right? Now we already have y on the outside, so this is it, right? Now we can easily double check our answers. when it comes to these kinds of questions. All we do, so let's see if that is correct, right? So 2y minus 5x. So if I want to double check my answer, all I need to do is to multiply this out. So 3y multiplied by 2y is going to give me 6y squared. Then 3y multiplied by minus 5x is going to give me 3 by 5 is 15. So it's going to be minus 15. And then y by x is going to give me xy, right? And you realize you got back the same answer. So therefore, this had to have been correct to begin with, right? All right, so let's do the next part here now, right? Y squared minus 9x squared, right? So in this one here, right, so we have y squared minus 9x squared, right? Now again, you have two terms here and they are separated by a minus sign. So there is the possibility that I can use the difference of two squares. So to determine that, we need to look at this. Y squared, that's a square variable. 9x squared is also a square variable, right? Now, what I'm going to do, I'm going to write y squared, right? So this is y squared minus that 9x squared, I'm going to write it as 3x squared. Now, if you all remember what the difference of two squares is, if I have a squared minus b squared, I can factorize this and I'll end up with a plus b in one bracket, a minus b in the second bracket. So you all need to know this, right? This is the difference of two squares. So if I want to factorize this, this is going to be y plus 3x in one bracket and y minus 3x in the second bracket, right? So that's my answer there for that factorizing, right? So this here is my answer. Moving on, there are some questions you can get in the exam that looks like this, right? And some students, they get extremely scared in terms of how to deal with a question like this, right? So what I have here, I have 3 over x minus 1 minus 2 over 2x plus 1, right? So those are two fractions that we are trying to add. So what we're going to do, we're going to do it just like we do the subtraction of two fractions. I'm going to look at this here, x minus 1, and I'm going to look at 2x plus 1, and I'm going to find my LCM. Now those two variables are different, so if you're trying to figure out what the LCM is, all we need to do is to multiply those two variables, right? So x minus 1, 2x plus 1, that is going to be my LCM, right? So this here is the LCM of the x minus 1 and the 2x plus 1, right? Now this is where things get a little tricky for some students. What I need to do, I need to take the LCM. So first step is to take the LCM here, and I'm going to divide it by this denominator here, right? So let me show you exactly what I'm doing here. I'm going to take x minus 1 in one bracket, 2x plus 1, and I'm going to divide it by, so you're going to divide it by this here, right? So I'm going to put x minus 1 here, and what you're going to realize is that this will cancel with this, and I will end up with 2x plus 1. Now what do I do with that now? So that 2x plus 1, I'm going to take that and I'm going to have to multiply it by this numerator here, right? So when I do that, I'm going to end up with 3 multiplied by 2x plus 1, right? Now this question is very tricky, right? Especially for those students who are not strong in algebra. You're going to write back your minus sign, right? Because you're subtracting two fractions. The next thing I'm going to do, I'm going to take the LCM again, which is x minus 1, 2x plus 1, all over, and I'm going to divide it by this denominator now, which is 2x plus 1, right? Now what is going to happen here, something is going to cancel again, right? So in this case here, this 2x plus 1 is going to cancel with this, and I'm going to end up with x minus 1. Now when I get that answer, now I have to take that answer and I have to multiply it by this numerator here, right? So what we're going to end up with is 2 open brackets x minus 1. And now we have to simplify this thing now. So we have to simplify the numerator, right? So we're going to leave the denominator as x minus 1, 2x plus 1. So this is what I'm going to do now. You have to simplify the numerator. So you're going to have to remove your brackets. So this 3 has to be multiplied by 2x. That's going to give me 6x. Then I'm going to take this 3 and I'm going to multiply it by this plus 1. So I'm going to get plus 3 here. The next part is, and this is the part that gives students trouble, this here is minus 2 multiplied by x. So this is going to be minus 2x. And then minus 2 multiplied by minus 1 is going to give me positive 2. Now that is where the students tend to make the mistake when they are simplifying this. And CXC will tend to give us a question along those lines, right? So now let's go ahead and continue simplifying. So the top part there now, we have x's and we have constants. So let's bring all our x's together. So 6x minus 2x plus, plus 3 plus 2 all over x minus 1 by 2x plus 1, right? So when I simplify the numerator, I'm going to get 4x, and 3 plus 2 is going to give me 5, all over x minus 1 by 2x plus 1, right? So that's it. This is my final answer here at the bottom here, right? So these questions, they tend to be very tricky. So you're going to have to be very, very careful, right? So just be aware of that, right? So let's do our next one here now, right? So this one is a substitution question, right? I have y is equal to mx plus b, right? And they told me what m is, what x is, and what b is. And they want us to find the value of y. So m is minus 2, right? Now in this formula here, it's m multiplied by x. So we have to multiply by minus 7, right? And then we have to add b, so it's plus minus 3. Now when students get questions like this, they get very confused with the negative signs. So we need to work out the brackets first. So minus 2 multiplied by minus 7 is going to give me positive 14, right? Plus minus 3. That is the same as saying 14 minus 3, and that's going to give me 11, right? So this is a substitution question. It is something that can come in the exam. So the next one here now. Solve for x. So this is changing the subject of the formula. I have y is equal to qx over p. And the question seems very simple enough, but there are lots of students who have great difficulty with this. So what I'm going to do, I'm going to write y as y over 1. Because if I have a number, let's say I have 5, right? And I say I want to write that as 5 over 1. 5 over 1 is the same as 5. So if I want to write a number or a variable as a fraction, just write it as y over 1 or x over 1 or whatever over 1, right? So y over 1 is equal to qx over p. And what that allows me to do is to cross multiply. It may seem a little trivial, but this helps and it goes a long way. So when I cross multiply, what I can do, I can say y by p is equal to qx by 1, right? So that is cross multiplication. That's what I'm doing here. So cross multiplying, right? That's what I'm doing. So when I do that, y multiplied by p, right? Y multiplied by p will give me yp, and qx by 1 is going to give me qx. Now let's be aware of what we're trying to find, right? We're trying to make x the subject of the formula. So what I'm going to do, I'm going to write this as qx is equal to yp. Now whenever I make a statement like that, some students ask, so why didn't you change the sign, right? And I want you to ask yourself something. If I were to do something like this, let's say 5 is equal to 1 plus 4, right? I can also write that as 1 plus 4 is equal to 5. These two statements are equivalent. And you notice I didn't change the sign. So if I have yp is equal to qx, then qx is also equal to yp. Now this step here is crucial because it helps those students who can't visualize simplifying this thing, right? So I want to make x is subject of the formula. So all I need to do now is to just divide by q. So yp over q. And that's my answer there. That's it. Alright, so moving on. I'm just going to do as much as I can this morning here. Solve the system of linear equations, right? So we have a pair of simultaneous equations here. We have 2x plus y is equal to 3 and 3x plus y is equal to 1. Now, whenever you have or you're given a question like this in the exam, please go ahead and label your equations. So that's equation 1 and that's equation 2. Now, there are different ways we can solve a pair of simultaneous equations. One, right, you can do it using a graph, right? You can do it using substitution. Right? You can do it using elimination, right? And the fourth method is what we call a matrix method, right? So there are about 4 different ways we can solve a pair of simultaneous equations. And how do you determine which method is to be used in the exam? Well, it depends. If it comes as question 2 in the exam, there's a good chance we have to either use substitution or elimination, right? If it comes later on in the paper and they ask you to draw a graph, then we're going to draw a graph to find the answer, right? And then if it comes as question 10, then we know we have to use a matrix method. They will tell you so. They will say using a matrix method solve. So this pair looks like an easy simultaneous equation, right? And what I'm going to use elimination. So in the first equation, I have y, and in the second equation, I also have y. So what I'm going to do is to simply subtract both equations, so I eliminate y. So I'm going to say equation 1 minus equation 2, right? So 2x minus 3x, right? That's what we're doing. So 2x minus 3x, right? Y minus y is going to give me 0. Put back equal sign. 3 minus 1 is going to give me 2. Now 2x minus 3x is going to give you minus x is equal to 2. So therefore x is equal to minus 2. So I have just solved for what x is, right? The next step is I need to figure out what is the y value, right? Because in a system of linear equations, now the graphs here is just for illustration purposes. What we are actually doing here is we might have one graph that looks like this, and we might have another graph that looks like this. And where these two graphs intersect, that is going to give me my solution to my equation. When this graph, when these two graphs cut, I'm going to get an x value, and I'm also going to get a y value. So there are two answers that we should get when we are solving a pair of linear simultaneous equations. So what we need to do, we need to figure out what is y. So I'm going to take y, and we're going to substitute that into any one of our equations. So substitute x is equal to minus 2 into equation 1. Doesn't matter. We're going to get the same answer either way. So it's going to be 2 multiplied by minus 2 plus y is equal to 3. 2 by minus 2 is minus 4 plus y is equal to 3. So y is equal to 3 plus 4. So y is equal to 7. So these are my two values here. X is minus 2 and y is equal to minus 7, right? All right, let's give me a sec here. Hold on now. Alright, so we have our next question here. Let's see what this is, right? Simplify. So this has to do with indices. So there are several rules that you guys need to know when it comes to indices. I'm just going to recall those rules. So if I have a to the power m multiplied by a to the power n, all I do is I add my indices, right? If I want to divide, so a to the m divided by a to the n, it's going to be a to the power m minus n. So you all need to know all of these rules when it comes to indices, right? I'm not saying all of these are being applied to this question, right? I'm just recapping the rules. If I have a to the power m raised to the power n, then it's going to be a to the power m multiplied by n. We also need to know that anything raised to the power 0 is going to give me 1, right? We also need to know that a to the power minus n can be written as 1 over a to the power n. We also know that a to the power m over n can be written as a to the power m, and we find the nth root of this. So these are all my rules regarding indices, right? So I'm not saying we're going to use all of them here in this question. So 16p to the power 16, and I'm going to raise all of this to the power a quarter, right? Now 16 can be written as 2 to the power 4. How do I know that? 2 multiplied by 2 to the power 4 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 2, right? That is going to give me 2 2s are 4 2s are 8 2s are 16, right? Now 16 can be written as 2 to the 4, right? And this here is p to the power 16, and I'm raising this all to the power a quarter. Now I'm going to use the rule that I'm going to use here is this rule here, right? So 2 to the power 4, right? I'm going to raise that to the power a quarter, right? And the p to the 16, I'm also going to raise that to the power a quarter. Now if I apply this rule here, I'm going to get, if I take 4 and I multiply by a quarter, I'm going to get 1. So I'm going to get 2 to the power 1. And if I have 16 multiplied by a quarter, I'm going to get p to the power 4. So therefore my answer is simply 2p to the power 4, right? Alright, somebody's asking if I would get the same solution to the previous question with the matrix. Yeah, right? But don't waste your time using the matrix method if they didn't ask us to do this, right? Alright, so let's move along. Right, I have an inequality here that I want to solve. N plus 7 is less than 5n minus 8. So what I'm going to do, I'm going to carry all my n's to one side. So this is going to be n minus 5n is less than minus 8 minus 7, right? So n minus 5n is going to give me minus 4n, less than minus 8 minus 7 is going to give me minus 15, right? So in this scenario here now, we need to divide by negative 4, right? To solve this thing here, we need to divide by negative 4. So minus 4n divided by negative 4 is going to give me positive n. But because I'm dividing by a negative sign, I need to change the sign of this inequality. This is one of those tricky questions, right? When you divide by a negative number, I must change the sign. So this is going to be now minus 15 divided by minus 4. And therefore n is greater than 15 over 4, right? So let me just double check and make sure that's correct. N minus 5n is minus 4 minus 8 minus, yeah, that looks about right. Alright, somebody's asking if I've done a video on inequality. I think there may be, right? I'll double check. Let's see what this next one here. So this one is a variation question. Y varies directly as a positive square root of x. Now, we need to be able to take these words. So y varies, that's a proportional sign, directly as a positive square root of x. So we're looking at the square root of x, right? That is what the statement here means. Y varies as the positive square root of x, right? So the reason why they use the word positive square root here is that the square root of any number, let's say 16, I can get positive 4, right? Or I can get negative 4. There are two answers. If I find the square root of 9, there are two answers, positive 3 and negative 3. So what they are saying, we are only concerned about the positive square root, right? Now, they have given me some information here. They said when x is 9, y is 12. But the first thing I need to do here, that proportional sign needs to be removed. So y is equal to k times the square root of x. So a proportional sign can be replaced by putting an equal sign, but we must introduce a k into my equation. Now normally they will give us information to figure out what this k is. So y is equal to k times the square root of x, right? So we know that x is 9 and y is 12. So this is 12 here. This is k, and we're looking at the square root of 9. So therefore 12 is equal to k. The square root of 9 is going to be equal to 3. So therefore we can say that 3k is equal to 12. So k is 12 over 3. So therefore k is equal to 4, right? So I've just figured out what k is. So therefore my actual equation is y is equal to 4 multiplied by the square root of x, right? So all of these variation questions, the first thing that we need to do is to figure out what k is. If I don't have k, then I can't do anything, right? So let's see now. So now they said find the value when x is equal to a quarter. So when x is equal to a quarter, right, y is going to be equal to 4 multiplied by the square root of a quarter, which is equal to 4. The square root of a quarter is a half, so 4 by a half is going to give me 2. Right? So moving on, trying to do as much questions as I can, right? We have a question here. We want to factorize completely. And the first one is 2a plus 4 plus ap plus 2p, right? Now, like I said, there are 4 methods of factorizing. The first one is the ATF method. The second one is the difference of two squares. Then we have factorizing by grouping. And then we have factorizing a quadratic. Now, it is easy to identify the difference of two squares, right? Grouping is also easy to identify. If I see I have 4 terms here, then chances are it's going to be grouping, right? Now, when we say grouping, what we're going to do, we're going to look at similar terms. So I have 2a plus 4 and I have ap plus 2p. So what's happening here is that the first 2 terms, I can factorize that. I can factor out 2, open brackets, a plus 2, right? Now I have ap plus 2p. So if I were to factorize that, I can pull out p. So I can put p, open brackets, a plus 2, right? Now, the next step here now, you realize that you have a plus 2 common to both these terms. So to complete this, all I need to do is to write a plus 2 in one bracket, and the second bracket is going to be 2 plus p. So this here is factorizing by grouping. Right? So now, so that's the first one. The second one here is 162 minus 8t squared, right? Now, if we look at this here, we look at 162 and we look at 8t squared, you realize something looking kind of fishy there, right? It doesn't look like I can factorize anything as yet, right? So first step, I'm going to factor out, let's say 2. 2 is common to both of them. So if I factor out 2, then 162 divided by 2 is going to give me 81. minus 4t squared, right? So then some students might stop there and think, well, I'm done, right? But the problem is, if you look carefully, you will realize that there is a difference of two squares right here. 81 minus 4t squared is the difference of two squares, right? So therefore I can factorize this thing further, right? So I'm going to put 2 open brackets. Now 81 can be written as 9 squared minus 4t squared can be written as 2t squared, right? So like the previous question, remember you all need to know that a squared minus b squared is equal to a plus b in one bracket, a minus b in the second bracket. So what I'm going to do, I'm going to do 2 open brackets. So that 9 squared there, right, that could be written as 9 plus 2t, 9 minus 2t. So you realize, even though we had to do two things here. We had to use the HCF method in this line. So this here is HCF we're using, right? And then when we jump to this line, we're using difference of two squares, right? So let's do our next one here. So we have some simple equations that we are trying to solve. First one is x plus 7 is equal to 15, right? And I'm trying to solve for x in this question here. So basically x is equal to, you just need to carry across the 7 to the right hand side. So this is going to be 15 minus 7. So therefore x is equal to 8, right? So this is part 1 here. The second part now, we want to solve again, but this time we have 5 open brackets 3x plus 8 is equal to 10, right? Now on the left hand side we have to use our distributive law and we need to remove the brackets. So to do that, what I'm going to do, I'm going to say 5 multiplied by 3x first, and then I have to say 5 multiplied by 8. So when I simplify this, I'm going to get 5 by 3x is going to give me 15x. 8 by 5 is 40 is equal to 10. So therefore 15x is equal to 10 minus 40. So 15x is equal to 10 minus 40 is going to give you minus 30. And therefore x is minus 30 over 15. So therefore x is equal to minus 2, right? So this is a simple equation that we try to solve here, right? Alright, a club is arranging transportation for its members, right? Speedy buses charge $625 plus $15 per member, right? The function c of x is given by 15x plus 625, where x is a positive integer, models the total cost in dollars of the transport for x members, right? So sometimes in questions they give us worded information in order to model some situation here, right? So in this case here we have some bus, right? And the bus is charging $625 plus $15 for each member that is on the bus, right? So they give us a statement here, and they also gave us what that function will look like. So c of x is equal to 15 multiplied by how many members we have plus a fixed cost of $625, right? Now sporty buses now charges $117 plus $19 per member, and they want us to write a function that models the total cost in dollars, right? So the total cost in dollars, d of x, right, is going to be equal to Now you have, let's say you have X members and each member has to pay $19. It is going to be 19X plus 117, a fixed charge of 117, right? The total cost, so that's the answer for part 1, that's the answer for this. In part 2, the total cost is the same for both speedy buses and sporty buses. Write down an equation and solve it to find X. So I have two functions here. So you have the speedy buses, which is given by C of X is equal to 15X plus 625, right? D of X is equal to 19X, right, plus 117, right? Now they are telling us that the total cost is the same for both of them. So what that means is that 19X plus 117 is equal to 15X plus 625. Because remember, this here, C of X and D of X, that's a function for the total cost. They are saying that the total cost is the same for both of them, right? So what we're going to do now, so this is the equation that they want, and then they want us to solve it. So you're going to carry all your x's on one side. So 19x minus 15x is equal to 625 minus 117. So 19x minus 15x is 4x, right? 625 minus 117 is equal to 508, right? So therefore x is 508 divided by 4, and therefore this is going to give me 127, right? So therefore 127 members will make both total costs be the same. Right, this next one here, we want to expand and simplify. So we're not being asked to solve anything here, we have to simplify. Now we have some brackets here, and what we're going to do, we're going to use our distributive law to remove the brackets. So 7 by 2x is going to give me 14x, right? 7 by 3y is going to give me 21y. Then I have to take minus x by 14, that's going to give me minus 14x. And then I'm going to take minus x multiplied by x, and that's going to give me plus xy, right? So let's simplify now. We can bring all the like terms together. So 14x minus 14x plus 21y plus xy, right? And 14 minus 14 will give me 0, and then I'll end up with 21y plus xy, right? So that's my answer there. So that's a simplify. They're not asking us to solve anything. They're asking me to simplify, right? All right, so we have 2s is equal to t open brackets 5 plus v, right? And they want us to solve for v. So what they're asking us here to do is to make, right, v the subject, right? They're asking us to make v the subject, right? So 2s is equal to, what I need to do, I want to remove the brackets. So t by 5 is going to give me 5t, then t by v is going to give me tv, right? So the objective is to make v the subject. So I'm going to write this over as 5t plus tv is equal to 2s, right? So tv is equal to 2s minus 5t. So therefore v is equal to 2s minus 5t over t, right? So that's my formula for v, right? So I've changed the subject of the formula here. Right, so somebody asked me a question on the previous one, right? Can it also be y open brackets x plus 21? That's, who's that, Marissa? Yeah, you can do that as well, right? So what she's saying is that we can potentially write this as y open brackets 21 plus x, right? But it just said expand and simplify, so I would just stop right here. Right, next one. We have a system of simultaneous equations again, right? And once you have two equations, like I said, we have four methods we can use. So I'm going to call this equation 1, and I'm going to call this equation 2, right? And again, I'm going to use elimination in order to work this out here. So we have two options. Either we eliminate x or we eliminate y. Now, you have a 5 here, and you have a 7 here, right? So I wouldn't want to eliminate the x, right? If I have a minus 2 here and I have positive 4 here. So what I can do, I can multiply the first equation by 2. So I'm going to take equation 1 and I'm going to multiply that by 2. So I'm going to end up with 10x minus 4y is equal to 48, right? And I'm going to call that my third equation now. So what I'm going to be using now, I'm going to be using this equation and this equation here. So you have to ask yourself now, if I want to eliminate y, what do I need to do with equation 2 and 3? Some students, they say, well, here what? You have 4y and you have minus 4y, and they decide they're going to subtract. But you can't subtract, because if you take 4y minus 4y, I'm going to end up with 8y. So you're not eliminating y. So what I'm going to do, I'm going to say equation 2 plus equation 3. So I'm going to add equations in order to eliminate y. That's what I'm going to do. I'm going to add them, right? So let's see. So if I add those two equations, I'm going to end up, so I'm going to write it out so you see exactly what I'm doing. So 7x plus 10x, right? Then I have 4y, right, plus minus 4y is equal to minus 14 plus 48. Now I'm just writing it out like this so you see exactly what I'm doing. I am adding the two equations. 7x plus 10x is going to give me 17x, right? 4y minus 4y is going to give me 0. So that's my y being eliminated there. And then I have minus 14 plus 48, and I'm going to get 34, right? So therefore x is equal to 34 over 17. So therefore x is equal to 2. So just like that, I've solved for x, right? Now, since I know what x is now, I can take that and plug it into any one of the equations. Doesn't matter, any one you want. So I'm going to take, so substitute x is equal to 2 into, let's say, equation 1. Right? You can substitute in any one of them if you want, right? So this is going to be 5 multiplied by 2 minus 2y is equal to 24. So 10 minus 24 is equal to, 10 minus 2y is equal to 24. So minus 24, minus 2y is equal to 24 minus 10. So minus 2y is equal to 24 minus 10 is going to give me 14. And therefore y is equal to 14 over minus 2, and this here is going to give me minus 7, right? So I have x is equal to 2 and y is equal to minus 7, right? Alright, let me just go back here. Somebody's asking a question about if you are divided by t first. Yeah, it could have divided by t. So one other possibility for this particular question here, I could have gotten v is equal to 2s over t minus 5. Some of you all could have gotten that for your answer, right? So when it comes to changing the subject of the formula, sometimes there are slight different possibilities with your answers, right? Alright, so we have a next one here. We have 2 to the power r is equal to 1 over 16. Now this is a indices question. So look at what we're going to do here. 2 to the power r, right? 16 can be written as 2 to the power 4. 2 to the power r, 1 over 2 to the 4 can be written as 2 to the power minus 4. So therefore, r is equal to minus 4. If you're all wondering what rules I'm using here, right? One of the rules that I'm using here is that a to the power n, right? A to the power minus n can be written as 1 over a to the n, right? That's one of my rules that I'm using here. So this is my answer for part A. R is equal to minus 4, right? For part B now, we have 3 to the power t is equal to the 5th root of 3, right? Now I can write this as 3 to the power t is equal to, now this is 5th root, so this is 3 to the power 1/5, right? So therefore I can say that t is equal to 1 over 5, right? So those are those little questions that can come in the exam that you can potentially get it wrong, right, if you don't remember your rules. Alright, so let's see what's happening here. So in this question here, right, we want to write as a single fraction in its simplest form, right? Write as a single fraction in its simplest form. I have x squared minus 3x over x squared minus 9. So you see, when you get a question where they ask you for the simplest form, there's usually a trick involved in that question, right? So x squared minus 3x all over x squared minus 9. Now you want to simplify this, so there's a good chance that we may have to factorize either top and bottom or just the top alone. We don't know. So my numerator here, I can factorize that using the HCF method. I can factor out x, and this is going to be x minus 3 all over, and x squared minus 9 is the difference of two squares, so I can write that as x plus 3 in one bracket, and I can write x minus 3 in a second bracket. So this here, the numerator, we're using the HCF method, right? And this part here, we're using the difference of two squares. Right? Now, if you realize something here, this x minus 3 and this x minus 3, they can cancel, and you will end up with x over x plus 3, right? So that's my answer here. We are simplifying this, and that's it. It's simply x over x minus 3, right? Alright, I see somebody's asking about if I'm doing a crash course like I did last year, right? Well, honestly, I don't like to do crash courses, right? So this is just a review. So whenever I have a chance, I'm going to be doing some reviews with you guys, right? So this is just session 1. I'm going to have several more sessions before the real exam, right? I'm basically focusing on the challenging things for students, right? We have our next one here now, right? We have 3 over x minus 4 plus 2 over x plus 5, right? So this is what I want to do. And I want to simplify this. So I just did a question like this for you guys, right? So I want to work out 3 over x minus 4 plus 2 over 2x plus 5, right? And we're going to add this. First thing we need to do, we need to find the LCM. So because the x minus 4 and the 2x plus 5, they are different, the LCM in this case is simply going to be x minus 4, right? Open brackets 2x plus 5, right? That's what's going to be my LCM. So just like we did in previous question, we're going to take our LCM. So you're going to take x minus 4, open brackets 2x plus 5, all over, and I'm going to add, sorry, I'm going to divide it by x minus 4, right? So this will cancel with this, and you will end up with 2x plus 5, right? So when I get an answer, I have to take that and I have to multiply it by this number on top here. So this is going to be 3 open brackets 2x plus 5, right? Put back your plus sign. I'm going to take my LCM again, that's x minus 4, 2x plus 5, and I'm going to divide that by 2x plus 5, right? So this here is going to cancel with this, and you're going to end up with x minus 4. When I get that answer now, that here has to be multiplied by 2, right? So this is going to be 2 open brackets x minus 4. Your next step now is to simplify the top part of this thing here now. So you need to remove your brackets. So 3 multiplied by 2x is going to give you 6x. If I take 3 by 5, I'm going to get 15. If I take 2 by x, I'm going to get 2x. And then if I take 2 by minus 4, I'm going to get minus 8. All over x minus 4, 2x plus 5. Right? So the numerator now, let's bring all our x's together. So I'm going to write 6x plus 2x plus 15 minus 8 all over x minus 4 over 2x plus 5. Right? So that's going to give me 6 plus 2x is going to give me 8x, and then 15 minus 8 is going to give me 7 all over x minus 4, 2x plus 5, right? So that's my answer there. That's what I'm going to get when I simplify this thing, all right? Alright guys, so this is how much time I have available now, right? I may be doing a session a little later, right? So what I suggest you guys do is hit like and subscribe, right, to the YouTube channel, right? And you will know when I go live, right? So that's it. That's all the time I have available right now. So I may see you all this afternoon, right? I hope this session was good for you guys, right? So please hit like, hit subscribe, and I will see you all soon, right? Take care, guys.